Your lesson online.
Okay, so those of you that have your journals, we should be on page 13. If you don't, you're just following along. Waylon, go ahead and read that problem there, the solve it problem on page 13.
You order pizzas and sandwiches. You have a budget of $80. How many sandwiches can you buy? Can you buy 4 pizzas? 5 pizzas? 16 pizzas?
Okay, so somebody's got a big budget and they're buying some pizzas and sandwiches. So they have $80. So see if you can figure this out. If you have, without writing anything down on paper right now, if you buy 4 pizzas, how many sandwiches can you get?
Like 20.
Like 20? There's a better answer than like
How can you
20.
find out exactly how many? It's like 8, okay.
It's like 8? Okay.
Wait, so 20 and 8 are very different answers, right? How can we know for sure without just guessing?
Because you multiply 10, like, you did 4, right? So that's half of 80.
Okay.
And then 4, and then 5 is half of 10, so that's.
Okay, so those, to use some number sense, she said that it's $10 a pizza. She's buying 4 pizzas. That's $40. That's half of 80. So there's $40 left. And then how many times will 5 go into 40? 8.
8 times. Okay, so if they buy 5 pizzas, how many sandwiches can you get? 6. And now we're going to show you the algebra that you're doing in your head. She almost talked you through the whole solving the equation process. Okay, so here's what we know. Well, they've got $80 to spend. And they're going to spend that on pizzas that cost $10. And sandwiches that cost $5. So how many variables do we have we're working with? We're working with pizzas and sandwiches. That's 2 different things, right? That's 2 variables. We're going to assign 2 different variables to those items. So we're going to make X equal our $10 pizzas. And we're going to make Y equal our $5 sandwiches. And now let's see if we can come up with an equation. Anybody want to take a shot at the equation? Let me help you out a little bit. Something equals 80. What equals 80? How do I write that pizzas cost $10? 10x plus not 5x, but sandwiches we're using the letter y. So how about that? 10x plus 5y equals 80. This is called a literal equation. It's called a literal equation because we have more than one variable. So unlike the equations that we saw in the previous unit where we're just like solving for x, we have one equation. This time we're going to have, one variable. This time we're going to have multiple variables. So this is a literal equation because I have x and y. We were trying to figure out how many sandwiches we could buy if we figured out how many pizzas we could buy. So let's solve this for sandwiches. In other words, we're going to solve for y. We want y to be itself. And so we're going to mess with our equation here and make a sandwich equation. Okay? So it's all the rules that we've already learned in solving equations where we're doing opposite math and we isolate our variable, right? We use skid. And that's what we're going to do here. So what I'm going to do is I'm going to box in my variable term that I want to isolate. So I'm going to box in the 5y. So what do we need to get rid of? Or what do we need to move or out of there? What's over there with that 5y? 10x. So how do we get rid of that? How do we make it cancel? Not divide. Subtract. Exactly. I'm going to minus 10x. Whatever we do to one side, we do to the other. Okay. So now my 10x's are going to cancel, and that leaves me with 5y equals what? What's 80 minus 10x?
78.
Oh, is it? It's just, I think I heard somebody, it's just 80 minus 10x. I can't put those together. Those are not like terms. One has an x, one doesn't. So I'm going to bring both of these terms down. So I'm going to have 80 minus 10x. And that brings us to our last step. And what's our last step? What do we do lastly? We divide. If I want y by itself, right now I'm multiplying by 5. I do the opposite. So I'm going to divide by 5. And whatever we do to one side, now the other side has 2 terms, which means both of those terms we're going to have to divide by 5. Okay, so that's going to cancel. And now I have y equals, what's 80 divided by 5? I might need my calculator. It is 16. What's 10 divided by 5? 2. So then we have minus 2x. And we have our new sandwich formula. We can figure out how many sandwiches we can buy if we know how many pizzas we're buying. Now let's do we already figured it out, using our brain, and we were like, okay, I know that pizzas cost $10, so I multiply times 10. I take that away from 80, and then I divide by 5. That's how we did it initially. But now we have a formula, and we're going to use the formula. If I plug in a 5 for x, meaning I'm going to buy 5 pizzas, what's 2 times 5? 10. What's 16 minus 10? What's 16 minus 10?
6.
6, which means if I buy 5 pizzas, I can buy 6 sandwiches. If I buy 4 pizzas, what's 2 times 4?
8.
What's 16 minus 8? 8. If I buy 4 pizzas, I can buy 8 sandwiches. So it's a little formula, okay? If I buy 7 pizzas, what's 2 times 7?
14.
16 minus 14 would be 2. I can buy 2 sandwiches.
So the power of these equations is once you get it, you can just plug in numbers and figure out what the other value is going to be, just like that. And the other thing is, on purpose, we solve for y. You could have just as easily solved for x, and you'd have a different equation where you could plug in the number of sandwiches you buy, and you'd automatically know how many pizzas you buy. You can solve for whichever one you need to solve for.
But notice that the math, even though we have multiple variables, I mean, not the math, the steps, the process is still the same as we were doing with our regular equations, right? Okay, let's turn to page 14. So turn the page over. And we have a problem up there under letter A, problem 1. Solve the equation 4 equals 2m minus 5n for m. What are the values of m when n equals -2, 0, and 2? Okay, so the directions say to solve that equation for m. In other words, that's the variable I want to get by itself. I want, when I'm done, to either be m equals or equals m. Okay, as long as the m is by itself on one side. So, because that's kind of small, I'm going to rewrite the equation. I have 4 equals 2m minus 5n. I want to solve for m. Okay, so m right now is not by itself. I've got some other stuff over there with it, another term. What do I do first? How do I get the m term by itself?
Bring it down.
No. What's over there with it?
Simplify.
What's over there with it?
Oh, the 5.
The 5n. So how do I get rid of that 5n?
What's the opposite math you would use? Plus. There you go.
Plus 5n.
Minus 5n, so we'll make it plus 5n.
And if I do that to the right side, I've got to do it to the left side. So my n goes away, my n term. That leaves me with a 2m. And over here, what's 4 plus 5n?
9.
Can I put these together? No, it's not 9. They are not
You'll
the
have to
same.
watch that when you're doing this because we're so used to just instantly combining things. Because the earlier problems we did were easier. These are, you can't combine things.
Yeah, they're not like each other, so you can't put them together. So we bring down both terms. We're going to have 4 plus 5n. There we go. Okay, so we want to solve, and we're almost there. M is not quite by itself. I'm multiplying by 2. That's what 2m means, right? 2 times m. So what do I do next? Divide. I divide everything by 2. Both sides by 2. Okay, so the 2's now cancel, leaving me with the m by itself. So I'm going to rewrite that over here. M is equal to, what's 4 divided by 2? 2. What's 5 divided by 2? 2.5, and that's okay to convert it to a decimal if you want. You could leave it like this fraction because it's already reduced, but I'll use yours of 2.5 plus 2.5 n. And that's our new equation. We have solved for m. We took what was given to us, rearranged it, and isolated m. We solved for m. And the next part of the question says, what are the values of m when n equals -2, 0, and 2? What do you think I do with those 3 numbers? Plug them in. Exactly. You're going to plug them in and then solve for m, and we'll actually get a number. So let's start with the easy one. Let's say that when n equals 0, what does m equal when n is 0? No.
0.
It is, what is 2.5 times 0? 0. So what does m equal? 2.
You just plug it into the place of that variable, and then you just do the math on that side.
Let's do when n equals positive 2. When n equals positive 2, what does m equal? Well, what is 2.5 times 2?
4.
It's 5. What's 5 plus 2? 7. So when n is 2, n equals 7. And then the last one, what about when n equals -2?
-7.
No.
Why? 2.5 times -2 is -5. And then what's -5? Yeah, -3, because you have different signs on your integers, so you subtract.
That's
Take
right.
the sign of the bigger number.
So now that we had a new formula, we took 3 inputs, we put it into our formula, and we got 3 outputs, okay? All right, and you can use this process for any equation that has multiple variables. So I'm going to go away from the book a little bit, and we'll just use some that maybe you have seen before. like this equation here. Anybody ever seen that equation before?
Yes, sir.
What is that? What does a D stand for? It's a distance formula. Distance equals rate times time. So it's a distance formula. If we know the rate and the time, we can calculate the distance. But let's say I want to rearrange this and I want to make it a time formula. So I want time to be by itself. What do I do to my equation to get t by itself? Just switch it? Good, I think you said, what did you say, divide by what? Good, divide by r. Because right now, this means r times t. I want t by itself, so to make the r go away, we do the opposite operation. We're going to divide by r. And if we divide this side by r, we have to divide this side by r. So we have a new formula. It's no longer a distance formula. It is a time formula, right, David? How about face forward, bud? Thank you, sir. Distance divided by rate. So time is equal to distance divided by r. There we go. So time is equal to distance divided by rate. We took a regular old formula, rearranged it, and made it to fit our needs. If now I want a time formula.
So now you guys are seeing why we were making sure you were showing your work with everything for the last test. Because this is stuff you can't put into InSolve. There's not even any numbers, and you're still doing algebra. So if you got in a habit, which I think everyone did, you're showing your work, you're doing the opposite math to move things across the equal sign, you're going to be able to do that. It's all the same steps that we already learned, but now you're just dealing with more variables than you used to.
All right, let's try another equation. Another one that you might have seen before. Let's do this one. What formula is that? That's a pi symbol. Sorry, I missed it. Huh? Circumference. Circumference is equal to 2 pi r. So that's a circumference formula. But let's make it a radius formula. So let's get r by itself. So how can I get r by itself? What can I do to both sides? Divide by what? 2 pi. I want the r to stay. I want to cancel out the 2 pi. So I can do it in one shot. Instead of doing 2 and then coming back and doing pi, I can do it all in one move. Divide both sides by 2 pi. Now this cancels, and now we have a radius formula. Radius is equal to the circumference divided by 2 pi. So if I knew the circumference, I could tell you what the radius is of your circle. Give me the circumference, I'll tell you the radius now. Okay? Okay, let's do one more in the book before we give you an assignment to start practicing on your own. Let's do one more from the book. Let's go to number, problem 2 on page 14. What equation do you get when you solve negative t equals r plus px for x? Wow, look how many variables we got there. We got 1, 2, 3, 4 variables. And I want x by itself. I'm going to rewrite this just so we can see it a little bit bigger. Negative t equals r plus px. Okay, there's my term with the x. This is what I want to get by itself. So what's the first thing we're going to get rid of? The r. How do we get rid of the r? Good, subtract. Right now that's a positive r, meaning to add r. So we're going to do the opposite. We're going to minus r from both sides. It cancels. So I have negative t minus r equals px. We're almost done. We want x by itself. What is px? What is that operation going on? Multiply. So what's the opposite? Divide. So we're going to divide by p. Not by x.
Whenever you have letters just stuck together and there's no plus or minus sign in the middle, it automatically means they're multiplied together. Okay? So if you have to separate them, you'll separate them by division every time.
So if I divide this side by p, I can divide this whole side by p. And notice this time I put the whole expression over p. I mean, I could do them individually, but this looks a little bit neater because I know I can't divide t by p or r by p to simplify it further. So this is okay. So these p canceled, and now I have a new formula. We have solved for x. X is equal to negative t minus r divided by p. All right, doesn't that look cool? That's like real algebra looking. That looks kind of cool. Okay, Mr. H is passing out an assignment now for you to practice.